Okay, let's do a little tube testing here. Now, my older tube tester cannot do the tubes in this radio. They do not appear. The entire set does not appear in any of the listings I have from my other tube tester, which is kind of curious. There's tubes all around it, but this particular set, none of them appear in the listings. But they appear in this one. So, and this is our chance to use this again after nearly blowing it up there. I certainly don't want that to happen. So first thing we're going to do is turn down the filament to actually 1.1, lower than where it should be. That's because I do not want to damage the tubes that are in this radio. So the first one we're going to do, we'll do the output tube. The output tube is a 1C5. So let's go find a 1C5. There it is. Okay. 1.5. Signal is 1. Bias is 18H. Now we set these controls. 06345, 06345, 0700. Sensitivity 19. Plate set to C. Oh, F. Okay, there's a code in here. Code F. Code F. What's F? What's F? What is a code F? Code F. There. Meter will indicate short when leakage test switch is in position number 1. Okay, pull the tube out here. T5. C5. There's a 1C5 and a 1T5. Are they the same thing? Well, that's an interesting question. Let's see here. 1C5. 1C5 and 1T5. I'm just typing that right into Google. Pretty vague stuff. Commonly used radio tubes. So I'm going to also add the word substitute. Substitute. And let's see what it says now. Antique radio form. Any substitute for WD11. Well, that's interesting. WD11. I have a WD11. That's the just about the most rare tube there is. It's unique. No, this isn't going to help us with our problem. There it is. Those 3D6 to WD11 bases were made by James Fred. Okay, I'm not going to read all that. Well, I'm going to bore you to death here doing this. Let's do a better search here. 1C5 substitute. Let's put the word tube in here, and then that'll focus down our search. Here we go. Doesn't look good so far. Let's try a radio museum. Similar to, and they don't list anything. I'm not sure you can just stick a 1T5 in the place of a 1C5. Let's look in here. What are we up against here? 1C5 uses base, well, it doesn't give a base number, it just gives the diagram right here. 1C5, 1T, QRST, 1T5, here it is here. 1T5 is a beam power tube, 1C5 is a power pentode. Okay, 1C5 has 3 grids, 1T5 has 3 grids. Okay. They are in order 5, 4, 8, 3. And on here, in order, they are 5, 4, 8, 3. Well, it's the same order, but the difference here is, oh no, no difference. 1, 7, and 1, so 5. Looks exactly the same. So what's the difference here? Glass octal type tube using output stage of battery operated receivers. Outline. This type may be supplied with pin number 1 omitted. Tube requires octal socket mounted in any position. Filaments, filament 1.4 and 0.1 amps. 1T5. Filament volts 1.4 amps, 0.05. 0.05, and the amps on this one for the heater 0.1. So this is actually a lower current tube. It's actually a better tube. Interesting. Okay, so I think a 1T5 can go in place of a 1C5. So we better dial this up to 1T5 now. That's another thing we can compare also. The settings on the tube tester. They reveal quite a bit. 1.5, signal at 2, bias 15H, 06, 3, 4, 5, same as the last tube, 07. Oh, exactly the same pinout as the last tube. Sensitivity 41. Plate on C. F. Warning. Voltage is 1.5, so we won't blow up the tube here. There we go. Turn on my tube tester. So short on 1. There it goes. You see the meter jump over on 1. A little too much light on here for you, don't I? There we are. Now you can see. I'll show you that again. Go 1, and the meter flies over. Okay, what else do we need to do with this one? Nothing. Just push the button. Push the button. And it's reading good. The actual reading should be over 750. It certainly is. So this is reading very good. Okay, so nothing wrong with that tube. Okay, we'll work our way back through the circuit here. Next tube would be the 1H5. 1H5 is you know what? The tube layout here on this diagram really doesn't match this radio 100%. Could just be bad drawing, or there is something different here. Curious about it. Okay, but the next tube would be the 1H5. Should be this guy right here. Here he is. 1H5, quite clearly written on it. 1H5, let's make sure I got that one in here. 1H5, there it is. 1.5, signals back to 1, bias, nothing. 07300. 07300. And 0600. Sensitivity 43. Isn't this exciting stuff, dialing this up? C. Grid cap. Okay, so I must put the grid cap onto it. Yeah, we'll have to do that with a clip lead or something like that. Plug her in. Or can that just sit on there? Oh, there's two sizes. What a nice tube tester. There we are. It's got the F, so we should see a short again in position 1. So we're watching the test meter as it goes through the shorts test. There's the short at position 1. Ready for the tube test. Any other special instructions? No. Here we go. And this should read above 180. It's well above 180. It's up around 500. Okay, now we switch to a diode test 07003. 0600. 48 sensitivity. EP on A. Still gives the same warning. There's the short again. Now this time we're testing on diode test. Diodes are good above this point here. It's good. So this tube tests good. Both halves, if this is a dual tube, both halves are working. Now the next tube is in a shield here. It has this grid cap. So the tube has come out here. There we go. Yeah, that's a nice looking tube shield. Yeah, that's better than all the ones I showed in that other video. Now notice that's only one tube that's got a shield on it. There. Oh, this is kind of a nice shiny tube. 1N5. 1N5. There we go. 1.5. Signal is 2. Bias is 0. 06340, 06340, 0700, 44 on sensitivity. C for the plate voltage, and the rejection point now is 490. Grid cap short during the shorts test. There it goes. And rejection point is 490, just under 500. So 500 is right around there on the meter. Right around there. Here we go. That's good. This is going really well. And now the last two. We're down to the last one. The last one is 1A7. Just getting the grid cap off here. There we go. 1A7, no doubt about it. 1A7, 1A7. Oh, it's a dual tube. 1.5. 10L. 10L. 07345. 07345. 4600. 4600. Sensitivity is 24. C. And we're looking again for 490 or virtually 500. Grid cap, short on one, whole tube. Now it says whole tube. I mean, that's kind of obvious what that means. Why are they telling me that? Whole tube. What are they trying to say? Whole tube specifies that all elements in the tube are being tested simultaneously. Yes, that would be whole tube, I guess. 1.5 on the volts there. Don't want to blow up these tubes. Grid caps on. These tubes, they heat up. They're ready to go, just like that. Here's the short. And it's over 500. Oh, it's got another setting, another set of settings. Another set of settings. 1.5, 1. Bias goes to 0. I can pull this out. 07045. 07045. 3600. 3600. 42 sensitivity. On C. There we go. And let's test this guy using, oh, that's mighty low. Mighty low on that. 1A7. Let's double check everything. 1.5. Signals on 1. Bias is 0. 07045. 07045. 3600. 3600. 42 on sensitivity. So yeah, everything's set right. Oh, cap off. Cap off. Cap off. Okay. Cap off. Maybe that was the problem. Cap off. F. Yep. It says oscillator there. Why would it bother telling me that? Why did they write that there? Don't usually write the function of the tube on here, so must be a reason. What is the reason? Oscillator. Oscillator. Oscillator section of the tube is being tested. Okay, there we go. And it tests good. It should be up over 500, and it is. So these tubes are testing very good. They are testing very good. So that's great news. All the tubes test good. Fantastic. That's fantastic. You know, I guess in a way, it's so important for tubes to be perfectly airtight for them to do their jobs. That airtight nature seals the inside of the tube and protects it from the environment. We shouldn't be too surprised if a tube that's been sitting around is in like-new condition. I wonder how true that really is, because I'd never read anything really about that. So I know other components that have been sitting around. You can't rely on them staying young. Like capacitors and that, to get moisture in them. Okay, so that's it for the tube testing. That's our big thumbs up on that one. And now we're on to other matters.